Hi, welcome. If you have been watching the previous videos, you would have known that we looked at the Aliquot method of weighing solids. Now we're going to be looking at the Aliquot method of measuring liquids. It's the same principle, but the difference is that we're measuring a liquid. So this is an example that we'll use to demonstrate this method. A formula calls for 0.5 milliliters of potent drug X. The pharmacist only has available a 10 milliliter measuring cylinder, graduated in 1 milliliter divisions. Between each 1 ml division, there are 4 divisions. Explain how you would advise her to measure the required volume using the Aliquot method. So the first thing, just as we had done with the Aliquot method for weighing, we determine the least measurable quantity. This is a little bit different from the determining the least weighable quantity using a scale of a particular scale, So in determining the least measurable quantity, you need to determine the 20% of the capacity of the measuring device. A measuring device is 10 mils, so therefore 20% of 10 mils is 2 mils. So that means to accurately measure a volume using a 10 mil measuring cylinder, you should measure anything 2 mils or above, up until 10 mils obviously. But if you measure anything less than 2 mils, the accuracy and precision will be reduced. And so we always want to determine what our least measurable quantity is. So because we were told that we needed to measure 0.5 mils of the potent drug X, it simply means that 0.5 mils cannot be accurately measured using a 10 mil measuring cylinder. So what's the next step? Step 2 says that we have to select a multiple. Least amount measurable divided by the quantity required. But here we're going to use the least amount that's measurable, which is the 2 mils, and the quantity we require to measure is 0.5 mils. So of course our multiple is going to be 4. So a larger multiple than what has been calculated may be used. This allows the least measurable quantity to be exceeded. This really just means that the amount of drug that you're actually going to end up measuring will be greater than the least measurable quantity. In this example, we are going to use the calculated multiple, but you are at liberty to use larger than 4. So you could use 5, you could use 6, you could use 7. The issue with this though, and it's not really an issue, but if you were to be preparing something to sell to a patient and the cost of each milliliter of the potent drug is say 50 US, you want to make sure that the amount of actual drug that you're going to measure is conservative. So you don't want to measure too much because you're going to have to charge the patient for that. But if you use the least measurable quantity, it means that you will maintain a conservative amount of drug to be measured, which can translate to economics in relation to the patient. So we have to think about all of those things. So the next step is now to determine the total drug to be measured. And if you recall, to determine the total amount of drug to be measured, you multiply the multiple by the volume that is requested. The volume that's requested is 0.5. And when we multiply the multiple by 0.5, we get 2 mils, which works out to be the least measurable quantity. If you use a value greater than 4, as I was discussing in the previous slide, then it means that the amount of drug that you're actually going to be measuring is going to be more. So let's look at this practically. If you had 2 pharmacies and this patient went to both pharmacies to determine how much it will cost to get this 0.5 milliliter of potent drug, and say the potent drug cost $100 US per mil, then it means then that if the patient came to pharmacy A that decided to use the least measurable quantity, will charge much less than pharmacy B, who decided to use a multiple of 5 and ended up measuring 2.5 mils. So we try to be as conservative as we possibly can. So the next step is to determine the total quantity of mixture to be prepared. And the total quantity of mixture is going to be the amount of drug that you're actually going to measure, which is the least measurable quantity in this case, plus a certain amount of vehicle to make a total mixture. So you're going to dilute the quantity of drug to be measured with an appropriate vehicle, which could be water. So the quantity of drug to be measured is 2 mils and the multiple is 4. So therefore, total quantity of mixture to be made would be 2 mils times the multiple, and you got 8 mils. So that means 8 mils of the total mixture will be made. So what does this mean? You need to determine now the amount of diluent that will be needed to make that 8 mil mixture. So total mixture minus total quantity of drug to be measured will give you the diluent you need to add to the least measurable quantity of drug that you'll be measuring to get the total mixture. So 2 mils minus 8 mils is going to give you 6 mils, and that means 6 mils of the diluent needs to be mixed with 2 mils of the potent drug X to get a final mixture of 8 mils. Okay. So the next step now is to determine what proportion of this 8 mil mixture must I now remove that will have the 0.5 milliliters of the potent drug that I want. Because we're using Aliquot method, you are now going to divide the total mixture that you have by the multiple to determine the aliquot that should contain the 0.5 mils. So we can double check this using ratio and proportion. If 2 mils of the potent drug X is contained in 8 mils of total mixture, then 0.5 mils will be contained in X, and that works out to be 2 mils. So what we had calculated was indeed correct. So what does this mean? Our new formula is going to be potent drug X. You need 2 mils of it, and diluent, you need 6 mils. You mix these two volumes together, you get 8 mils, and then you remove 2 mils that contain your 0.5 mils of potent drug X. Another way of writing this formula would be to say potent drug X 2 mils and liquid diluent QS 8 mils, and the liquid diluent could be water. And of course, you're going to be calculating the concentration, and the concentration would be amount of drug in total mixture times 100%, which works out to be 25%. So going forward, if you're using a 10 mil measure and you want to measure 0.5 milliliters, then making a 25% volume in volume mixture should allow you to weigh that small amount. You mix these you mix 2 mils of potent drug X, make it up to volume to 8 mils with a diluent, possibly water, and from that 8 mils you remove 2 mils that will contain 0.5 mils of drug. Thank you so much.